Now this is a chemical calculation question, and I would categorize it under the concept of reacting mixtures. Okay, so whenever you have a chemical calculation question where the reactants it consists of a mixture of two different substances, then it falls under this category. Okay, so in this question, if you read, we are reacting two substances, methane and ethane, with oxygen. Okay, we're going to learn later on that combustion is actually the reaction of a substance with oxygen. Okay, and combustion of hydrocarbons, meaning compounds containing carbon and hydrogen only, would produce carbon dioxide gas and gaseous water only. Okay, so the difficulty in this question lies in the fact that now instead of having only one reactant, we are reacting a mixture of two hydrocarbons or two substances with oxygen. Now, a common mistake that students make is to combine the two equations together. Now, that is not correct, because when you combine the two equations together, you are assuming that you have the equal amount of both substances. Okay, the way to solve questions like this is to use algebra. Okay, the most straightforward way to solving this question is by using algebra. Now, in part A and part B, you are required to write the equations for the combustion, which I have already done so. Then, what do I mean by using algebra is this. When you have a mixture of two reactants, you can let X represent a certain amount of volume of one reactant, and let Y be a certain amount of volume of the other reactant. For example, now in this case, since we are dealing with all gases, okay, remember when you have gases as reactants and products, Avogadro's relation would come into play. So molar ratio equals to volume ratio. In this case, I will let X be the volume of methane, and I will let Y be the volume of ethane. Okay, so that's always the first step to solving reacting mixture questions. Let X be the amount of one reactant and let Y be the amount of the other reactant. Once you have done so, the next step is to set up a pair of simultaneous equations using X and Y. So what do I mean by that? We are given that the total volume of mixture is 7.2 dm cubed. So essentially X plus Y is equals to 7.2. Okay, so we have one equation of the simultaneous equation already. Now let's look at what else is given in the question. We are also given the volume of carbon dioxide gas, and we are also given the volume of steam that is produced in the reaction. Okay, so that will allow, these two pieces of information will allow us to come up with the other two simultaneous equations. And how do we do that is by going back to the equations. Now if we look at the equation in part A, right, now that we have defined X volumes of methane, by comparing mole ratio, if we have X volumes of methane, it will give us X volumes of CO2 and 2X volumes of steam. Okay, remember when we are comparing gases, mole ratio is equivalent to volume ratio. Similarly, for the equation in part B, now that we have defined Y volumes of ethane, on reacting, it will give us 2Y volumes of carbon dioxide and 3Y volumes of water. Okay, so now that we can express the volume of carbon dioxide form and steam form in terms of X and Y, we can set up the other two equations. The volumes of CO2 combined would be equals to 12 dm cubed. This is the second equation. And then the volumes of steam combined would be equals to 19.2 dm cubed. Okay, now that we have 3 equations, we have more than enough equations to solve for the 2 variables. So let's apply your mathematics. For example, if we take 2 minus 1, okay, we will end up with y equals to 4.8 dm cube. Okay, and with that we can find that x is actually 2.4 dm cube. Right, now that we have found the volume of x and y, meaning the volume of methane and ethane, we can easily find number of moles by taking volume divided by molar volume. So number of moles of methane would be equals to 2.4 over 24, which is equals to 0.1 moles, and number of moles of ethane would be 4.8 over 24, which is 0.2 moles. Okay, so even though the question looks complicated, once you know the approach to solving reacting mixtures, it becomes very, very simple. So lastly, I just want to stress this again. When you encounter a reacting mixture question, always use algebra. Let the amount of one component of the mixture be x, let y be the amount of the other component. Okay, then immediately you can set up one equation, and from the amount of products formed you can set up the remaining simultaneous equation, and on solving the simultaneous equation you will find the amount of x and y.